And our second question deals primarily with integration by parts. Now, how do I tell the first question is a substitution while the second question is an integration by parts? The first question, my u prime is outside, or there's some both being powers that I need to deal with. I could solve the third question for Q1 using integration by parts, but substitution is a little bit nicer. But in these Q2 questions, x squared being inside, x cubed being outside, don't quite gel. They don't quite line up nicely, but an integration by parts can help. So for the first question, we've got the integral of x cubed sine x squared dx. Now, you could do a technique that we outlined in the course notes where it was, okay, pick your v, then your dv, then u. But a lot of students found it easier to do a substitution first and then integrate by parts. So a lot of students felt it easier to go u equals x squared, du by dx equals 2x, 1 over 2x, du by dx equals 1. So this equals x cubed over 2x sine x squared du by dx to give 1/2 integral x squared sine x squared du by dx which equals 1/2 integral of u sine u du by dx. And now they would do an integration by parts on this sine u. So they would say u, and here we would say w equals u, dv equals sine u, dw equals 1, v equals minus cos u. Then I teach this alligator method to remember what my formula is. So this is 1/2 times u, or u minus cos of u minus the integral of 1 minus cos u du by dx, which equals minus 1/2 u cos u plus 1/2 the integral of cos u du by dx. Now integrating this, I get minus 1/2 u cos u plus 1/2 sine u plus c. Finally, I substitute back in x squared equals u. Minus 1/2 x squared cos x squared plus 1/2 sine x squared plus c. And we have our solution. Now for our next question. It's going to be very similar to our first question, the integral of x to the 5 cos x cubed dx. Here, again, a lot of people found using a u substitution first was helpful. And what a lot of people do is they actually do a w substitution so they can keep u and v dv for their integration by parts. So w equals x cubed, dw equals by dx equals 3x squared, or 1 over 3x squared, dw by dx equals 1. So this equals the integral of x to the 5 over 3x squared cos x cubed dw by dx, which equals 1 over 3 the integral of w cos w dw by dx. dx. Now they let u equal w, dv equal cos of w, du equal 1, v equals sine of w. This equals 1/2 or 1/3 alligator w sine w minus the integral of sine w dw by dx, which equals 1/3 w sine w plus cos w plus c, which equals 1/3, replacing w with x cubes gives me 1/3 x cubed cos x cubed plus 1/3, or sorry, this is a sine x cubed plus 1/3 cos x cubed plus c. Remember your plus c. Finally, we have our last question for Q2. The integral of 2 plus x e to the x dx. Now, a lot of people here are afraid to split up this integral before they start, but I encourage you to do so. This equals 2 e to the x plus x e to the x dx, which equals the integral of 2 e to the x dx plus the integral of x e to the x dx. Now, this piece we can solve. That's simply 2 e to the x plus the integral of x e to the x dx. Now, you might be saying, okay, Tom, there should be a plus c here because you integrated. However, because this indefinite integral will also have a plus c, I can just keep that constant in mind and it'll pop out later when I solve this integral. Okay? Now, in this integral, I want u to equal x, dv to equal e to the x. The reason I pick u to equal x and dv to be equal to e to the x is when I derive x, it disappears. It becomes 1, and that x term is no longer there. And v, the antiderivative of e to the x, is simply e to the x. Again, take the alligator. This becomes 2 e to the x plus x e to the x minus the integral of e to the x dx, which equals 2 e to the x plus x e to the x minus e to the x plus c. And that is our solution.